welcome to the first lecture of Real Analysis 1. As we have discussed, for your first semester, there will be in all 5 theory papers and 2 practical sessions, right? Out of those 5 sessions, students are requested to mute themselves. Kanchan Shengi, mute kara swatala. As we have discussed in the last lecture, there were 5 theory papers in all. This was actually a syllabus. Okay, out of 5 theory papers, the first paper is Algebra 1. Okay, and the paper code is HCT 1.1. I will just tell you what is the meaning of this code. HCT represent hardcore theory, that is compulsory theory paper. 1.1 tells you a meaning that this is the first paper of first semester. 1 represents semester, point 1 represents the number of the given paper. Okay. Therefore, this is the first paper, Algebra 1, consisting of group, ring, polynomial ring, etc. This paper will be taught by Mr. Vinay Kambi sir. Okay. This was the second paper of Real Analysis 1. Again, the code for this paper is HCT 1.2, that is Hardcore Theory, Semester 1, second paper. This paper I will teach you, myself, Dr.Jyoti Mashai, I will teach you the paper. In this paper, we have 4 units in all. First is Riemann integration, second Riemann stretches, multivariable differential calculus, implicit function and extremum problem. And if you just give a look to the recommended books we are using for this paper are 2 different books. First is Mathematical Analysis by S.C. Malik and Savita Arora. Second is T.M. Apostle by T.M. Apostle Mathematical Analysis. Apart from this, we are using many other books for our references. The third paper of our semester is Differential Equation. Paper code is HCT 1.3. In this paper also you have 4 units and this paper will be taught by again Mr. Kandisar. Next, paper number 4 is Classical Mechanics. In this unit you have 4, in this chapter paper you have 4 units. This paper will be taught by Miss Uzma Muchalina. Okay, and last paper is Number Theory. If you look at this code, this is Soft Core Theory, SCT it is. Okay, the meaning of the word soft core theory is actually among the soft core one has to select the paper of your choice, but due to the unavailability of the faculty, here we are making the compulsion, and therefore for this semester your soft core theory will be number theory. Okay, and this is the paper taught by Mr. Vishal Kohli sir. There are references and all. This was second soft core theory paper, but we are not running this paper. If someone is interested to take this paper as the soft core, as their optional paper, where the heading is object oriented programming using C++, no doubt you can select the paper, but you have to make the study on your own. There will be no teaching for this paper. Okay. Next, we have practical session. There are 2 practicals as I mentioned early. Practical number 1, the paper code is HCP 1.1. Again, the paper code I will explain. HCP stands for Hardcore Practical 1.1. Semester 1, Practical 1.1. And this is LaTeX introduction actually. LaTeX is the typesetting software which is used to write the research paper, to type the notes, to write the books. Okay, because I don't know whether you have faced this problem early, that typing a mathematical equation in Word, Microsoft Word, it's more difficult for us because we are not getting all the symbols available on the Microsoft Word. Okay, that's why we are going to teach you this LaTeX software. From this year itself, we have introduced this. In practical 2, paper code is HCP 1.2. This is a second part of the LaTeX. Okay. While once we start the practicals, we will get it through done. Once we start the practicals. Okay. This is what about the syllabus is. Okay. Now myself, I am going to teach the paper of Real Analysis. I hope all of you are familiar with the paper of Real Analysis. I think you have studied this paper in your TYBSc, no? Whether you have studied Real Analysis in TYBSc?
Yes, ma'am.
SYPSC,
Yes,
ma'am.
ma'am.
In
Good.
SY.
Now what we will do, 2-3 lectures we will spend just to check how much you have understood about real analysis, the basic concepts. Because once I know how much is your level of understanding, accordingly I can start my syllabus. Okay. Now we should start with basic concepts of real analysis, which is helpful for understanding this paper of real analysis in your master's course, MSc first semester. Okay. Actually, there are two parts of real analysis. Real analysis 1 is in this semester. That of the second part of real analysis was covered in the second semester. The heading will be real analysis 2. Okay. Same thing happens for algebra as well. In first semester, you will have algebra 1 as a paper where the corresponding extension will be taken in the second semester. It is algebra 2. Okay, now what we have to do today is we will start with some basic concepts and you have to answer me what you know. Okay, and in real analysis, it is not only essential to know the definition, but also it is very important and essential to understand the geometrical aspect of the corresponding definition. Okay, means if I am asking you the definition of continuity or sequence convergence, xn tends to L, mod xn less than mod xn minus L less than epsilon for all n greater than or equals to N. This is the definition, but what you have understood as a geometrical aspect, that is important, and my focus throughout the paper will be on the geometrical aspect, because unless you understand the geometrical aspect of the corresponding definition, it is difficult for you to uh, go through the concept. Okay, before going to start, I just want to ask a question: which reference book or which recommended book you have used to study real analysis? Anyone, can anyone tell me what is the reference book you have used to study real analysis? Don't answer me. We have used notes whichever are given to us in the lecture.
मॅम निराली प्रकाशांचं वापरलं होतं आधी.
Acha, good, Nirali Prakashan. But Nirali Prakashan is not a reference book. This is a textbook written by some university
SK
teacher.
Mappa, ma'am. SK Mappa.
Good, SK Mappa. And what is prescribed in your syllabus itself? Which is the recommended book prescribed in your syllabus itself. तुमच्या सिलेबस मध्ये कोणता होता रिकमेंडेड बुक आठवतोय कुणाला Have you heard the name Mathematical Analysis by R.R. Goldberg? होता का?
Yes, ma'am.
Hmm. R.R. Goldberg is your recommended book. How many of you have used R.R. Goldberg's book?
Myself.
Yes.
How
We
many
have used it.
you have used it? Can you tell me the color of the front page?
Green have third fourth green and one fourth orange.
Good. Means at least you have opened it, right?
Yes, ma'am. We have studied from it.
How many of you have studied or read out the complete book of mathematics?
No.
Complete book. At least one name I want, because you are a graduate student of mathematics now, right? You are qualified to teach high school level now. Up to high school level, you are qualified now. You can teach up to 10th
Yes.
standard now, according to the eligibility criteria, right? Therefore, I just want to know how many of you have read out complete, at least one complete book of mathematics. Depend on your choice. You may take algebra, analysis, differential equation, whichever the book you like most. हम्म? वाचलंय का कुणी पूर्ण पुस्तक घ्यायचं मॅथमॅटिक्सचं पहिल्या पानापासून शेवटच्या पानापर्यंत आम्ही वाचलंय असं एखादं तरी पुस्तक आहे का जे तुम्ही मला सांगू शकाल ऍटलिस्ट वन बुक आय वॉन्ट एनीवन फ्रॉम द स्टुडंट्स येस स्टुडंट्स नो वन Okay, now what we will do from this year. Now we will start reading the complete book of mathematics. करेक्ट ना. समजा एखादी कादंबरी दिली आहे तुम्हाला मी आणि मी सांगितलं फक्त मधला एकच पान वाचा, 10च पानं वाचा, किंवा अशी गॅप गॅप मी सांगितली, समजा 40 ते 50 वाचा, 110 ते 120 वाचा आणि एवढंच वाचायचं. एवढंच वाचल्यानंतर तुम्हाला ती कादंबरीचा मतितार्थ कळेल का हो? कादंबरी छान समजेल का? समजेल का?
नाही.
नाही समजणार नाही का. तसंच मॅथमॅटिक्स आहे. Okay, the same thing is being applied to mathematics also. It is not expected from the students to read only the concept which is for your syllabus or which is for exam mainly. Okay, it was expected that you should start with the first page of the book. Suppose this RR Gold work, if you have started with, then you should start with the first page of the RR Gold work and you should go up to the last page. Then and then only you will get the thoroughly knowledge of real analysis. And the same thing I will say for the remaining papers also. For algebra, for differential equation, for PD, complex, topology. 20 papers you are going to study in all. Right now, 20 papers. Out of those 20 papers, 2 is option to you. In second semester and in third semester, you can select one paper other than mathematics from the other department. That is from statistics, from computer science, etc. Okay. Therefore, among 20, at least 18 papers you will study of mathematics. If you want a complete knowledge or thoroughly knowledge of the corresponding paper, you should follow this advice that you should read the papers, the books from the first to the last page. Okay. And therefore, this was a clear instruction. Second instruction is whenever you are going to study mathematics, try to study this from knowledge point of view, not exam point of view. Correct? From knowledge point of view, not exam point of view. Means sometimes students were doing mistake. I can say that suppose open set is an example. Open set is there for the question. If the question depends on open set will be there in the exam, then only I am going to study open set. Otherwise, I am not going to read open set. Okay, this should not be a strategy while reading or while studying mathematics. Though that concept, though that definition is there for your exam or not, you must read it because this is going to be added in your knowledge. Therefore, this was an instruction always for every batch from my side that you should study from knowledge point of view, not exam point of view. Okay, because sometimes we are doing this now. Suppose there was a big theorem with a proof of suppose 7 to 8 pages. You are going to think whether it will be asked to exam. You are going to ask to yourself, there is no, you are going to leave the theorem. But sometimes what is going to happen, though you are leaving a theorem, means you are skipping the meaning given by the theorem itself. Right? Therefore, we should go for exam. We should not go for exam point of view. We should go for knowledge point of view. And that's why in every class I am saying that always topper of the class is not a scholar of the class. Correct now? Topper and scholar are the two different concepts according to me. Right? Who is the topper of the class? Who is the topper of the class? One who is going to score more maximum marks, right now, will be the topper of the class. And who is the scholar of the class? Who? Yes, who is the scholar? Scholar is the student knowing much of the understanding, much of the concepts with understanding, rather I can say. Okay, he or she might get some less marks in mathematics or in the exam. So that is quite okay. But you should have a knowledge of mathematics whenever you are going to be there on the stage as a teacher. Because in the last lecture, many of you have told me that you want to be a good professor. You want to be a good lecturer. Okay, what are the qualities of the good lecturer then? You should explain your students between the lines. The part which is not written in the book, you must teach that concept also. That is what a quality of a good teacher. Now, how this good teacher is going to build up? By the knowledge, gain of knowledge, what you are going to do in this 2 years, throughout 2 years. Okay, now the first instruction is you should not only use the notes we are giving in the class, you should go for the recommended book we are recommended book prescribed in the syllabus itself. Okay, I'll repeat again. For real analysis 1 we are using two different recommended books. One is S.C. Malik's Mathematical Analysis by the author S.C. Malik and Savita Arora. This book we will use for first 2 units, and for unit number 3 and unit number 4 we are going to use a book of mathematical analysis by T.M. Apostol for multivariable differential calculus rather. Okay, therefore keeping these two instructions clearly in your mind, you should start your study. Okay, this will be an instruction. Second thing, whenever you are there in the class or whenever you are there in these 2 years, what I expect is you should be very curious about the concept, because generally what is my habit is to ask why to every aspect. Okay, you may know it among 2 3 lectures. Why is the always question, because whenever we are finding the answer for that why, finding the answers, there are many ways with you. What are the ways? A big friend of you, Google, is in your pocket now. Correct now? You can use Google, you can use textbook, you have teachers, you have friends. Okay, just go and discuss it. But the main aspect is to raise the question. Once we raise the question, okay, we will at least we will try to get the answer of that question. Therefore, very important fact is to get the question. ओके, प्रश्न पडला पाहिजे, एखादा डेफिनेशन, एखादी कन्सेप्ट. मी जेव्हा शिकवते वर्गात, मी रादर एनी टीचर, जेव्हा आम्ही शिकवतोय वर्गात तेव्हा प्रश्न पडला पाहिजे की हे असं का होतं, हे असं नसेल तर काय होईल. जोपर्यंत आपल्याला प्रश्न पडणार नाही तोपर्यंत आपण त्याची उत्तर शोधू नाही शकत. करेक्ट ना? Therefore, what I request is to ask the questions. Okay. Now let me go towards my paper. If you have any query regarding the structure, academic formalities, you may ask me at any time. Okay, or you can post on your WhatsApp group or on your Google Classroom. Okay, from tomorrow we are going to share the link of the lectures only on Google Classroom. Okay, therefore there will not be any instruction on the WhatsApp group always. Okay. Now I am presenting my screen. Please tell me whether the screen is visible clearly to you. Is the screen clearly visible?
Yes, ma'am.
Good. I have written a real analysis 1, lecture number 1 on the screen. Okay. How much concepts you have studied in your BSc? Can anyone tell me about real analysis? How many concepts you have studied? काय काय शिकलो आपण रियल अनालिसिस मध्ये? Functions,
Convergence of series, divergence of series, and
functions,
function,
open set, closed set,
open set, closed set, Cauchy sequence,
neighborhood,
and
countable sets.
Ma'am, bounded sequence.
Yes, bounded.
Limits.
bounded and unbounded sequence,
Good, unbounded sequences. Convergence.
It's the
positive term
interval.
series.
Yes. Interval, neighborhood, open set, closed set, right? Na?
Totally bounded and bounded.
Yes.
Totally bounded. Good. Completeness, connectedness.
Completeness, compactness.
Good.
Metric space.
Yes, most important is metric spaces. Limit point of a set, adherent point of a set. All these
least
concepts,
upper bound,
least upper bound, greatest lower bound,
greatest.
Sequence.
sequence, good, subsequence.
Series.
Test for checking the
Infining
convergence
series.
of sequence also, na?
Monotone.
Monotonic sequences and
Riemann integrable functions.
Riemann integrable functions. Riemann integration was there for your syllabus.
No, ma'am.
No, I didn't.
मग
मॅडम
Riemann
येस
integrable function कुठून आलं?
मॅडम औरंगाबाद युनिव्हर्सिटी होती ना माझी त्याच्यामुळे
अच्छा.
आम्हाला होतं.
ओके ओके गुड. मग तुमचं मग हे फक्त रिव्हिजनच होईल.
हा
आमच्या विद्यापीठातल्या स्टुडंटला नाहीये रिमान इंटिग्रेशन. अजून काय शिकलो आपण?
Comparison of series.
Good. Much of the points we have discussed, no?
Yes.
Now what we will do today, we will start with very basic aspect. Hmm? If the sons agree, mute yourself, please.
Yes, ma'am.
After giving answers, everyone is requested to mute themselves so that there will not be much of the noise. Whenever you want to speak with me, you just unmute and speak. Okay. Now, what I have decided today is to start with very basic concepts so that I can understand how much you are knowing. Correct? Okay. Now, the first point I want to discuss with you is before going to open set and close the sets also. Let me start with neighborhood of a point. Neighborhood of a point. Is the writing clear to everyone? Screen is also clear?
Yes, ma'am.
Yes, ma'am.
Yes. Can anyone answer what is the neighborhood of a point? One or two lecture I spend on just knowing how much is your basic concepts clear. Because once I start my paper of real analysis, there will be no time for me to go back and teach you the basic concepts. For 1 or 2, 3 days, you will spend to just clear your doubts, clear your queries, try to tell you the geometrical aspect behind much of that concepts and all. If you are knowing the concepts, it is very well and good that we can proceed further. Okay, this was just a test, kind of a test. Yes, can anyone answer what is the neighborhood of a point? Students?
Point containing itself and the point containing outside the area, somewhat area around it.
Area around it. Okay. That's good, but it's not exactly as our textbook definition, rather, right, ma'am?
Yes.
Actually, whenever I'm explaining a definition to students, I'm telling a textbook definition and its meaning also. Right? Now, can anyone else want to try what is the neighborhood of a point? Whatever she has told is also correct, but I want according to mathematics definition. First mathematics definition and then we will go for understanding it. Okay. See, I'll write the textbook definition and then we will discuss. Okay. If a neighborhood of a point is the set n, okay, contained in R. I'll write the definition of set n contained in R. Okay, what is R? R is the set of real numbers.
Real numbers.
Real number.
R is the set of real numbers is called, now I will use a shortcut for neighborhood NHB, is called neighborhood of a point A if there exists an open interval I containing containing A and contained in A, contained in N. That is, a point A is in the interval and the interval is contained in the set. Okay, therefore I will show you how it is going to work out. Suppose this is my real line. Okay, and let this be a set N. Okay, point A is said to be a neighborhood or a point A. If I start with, then this N is said to be a neighborhood of the point A if there exists an open interval, say I, around it containing A contained in N. Correct now? From the sketch, it is very clear that the point A is in I and I is in N. In that case, N is called as the neighborhood. I is also called as the neighborhood. That is, an open interval around the point is also called as a neighborhood. This was a case if I am considering a set of real numbers, that is on a real line. What will happen if we go in R2 plane? Okay, same definition, R2 plane. Okay, if this is a point in R2, R cross R, then what will be the neighborhood area? The neighborhood area around this point will be a disk. Correct now? Here it is an open interval, here it is an open disk we are seeing. And if I go further for R3, okay, if I go further for R3 space, what will be a neighborhood around a point?
Sphere.
A
Yes,
sphere.
it's an open sphere, and the symbol we are using is, suppose this is a point X, and if the sphere is having a radius R, the symbol we are using is S X semicolon R. Right now, this is an open sphere which acts as a neighborhood for the point X, and here open disk will act as a neighborhood of the point A. On the real line, open interval will act as a neighborhood of the point. Therefore, as you change your underlying domain space, accordingly the concept of a neighborhood is going to change. Okay. Now, in our paper, throughout we are discussing only for real numbers. Therefore, these two cases will not arise in our paper. Okay. Now I'll go for some examples. Okay, you have to answer the questions now. Example number 1. What about set of real number, whether it is a neighborhood of points? Set of real number, whole set of real numbers. Whether it is a neighborhood of its points? Okay, are you getting my question? This whole real line, if I consider whether it is the neighborhood of each of its points. Yes? You have two options only. Yes or no?
Yes, ma'am.
Yes, set of real number is neighborhood of set of real number is neighborhood of each of its points. Shall I write? प्रत्येक पॉइंटचा neighborhood आहे ना तो. Each of its points. Correct ना? समजा अशी एक रिअल लाईन आहे माझ्याकडे. This is a real line. कुठलाही पॉइंट मी घेतला A. तर काय होईल? Any small open interval around A will be contained in R. Therefore, R will be act as a neighborhood. Actually, R itself is an open interval, na? Minus infinity to plus infinity. Correct, na? R itself is an open interval. That's why this is R will be a neighborhood for each of its points. What about set of rational numbers? Whether set of rational number is neighborhood of its points. Q means rational. What is the definition of rational number? Yes, students, what is the definition of rational number?
The number of the form P by Q.
Yes, number of the form P by Q. P and Q both
not
are
equal to 0.
correct. Q not equals to 0 and P, Q both are
Belongs to R.
belongs to
Real
Z.
number belongs to Z.
Z integers. We want them as integers. Correct, na?
Yes.
Now, whether this set Q is neighborhood of its points.
Yes.
Yes. Okay. Is there any answer? Is there any other answer you have? Okay, suppose I am taking a number half. Is it a rational number?
Yes, ma'am.
Yes, it is a rational number, and I'll check whether set Q contains an open interval around half. Correct na? According to this definition, if this n has to be a neighborhood, then around the point there should be an open interval which is contained in the set itself. Therefore, here one point half I have taken and I have drawn a small open interval around it. I can write this is half plus epsilon and half minus epsilon. That is total distance I have taken epsilon on the left, epsilon on the right. That is 2 epsilon is the length of the open interval. Correct now? Now whether this interval is contained in the set of rational number?
Yes, because epsilon is so small that it can contain.
Tends to zero.
My question is whether this open interval is contained in Q or not.
Yes,
Yes, it
yes.
contains, madam.
Contained. Whole interval.
Not madam.
No.
Not neighborhood any
Open.
point.
Whoever is giving a no answer, can you tell me why this interval is not in the set Q? Hmm. बोला चुकलं तरी चालेल. If you are going wrong, don't worry. Here we are just discussing these points. Correct? मायनस इप्सिलॉन प्लस इप्सिलॉन. बरं अजून सोपं करूया आपण याला. हाफ मी घेतलाय. ओके. इकडे मी 0 करेन आणि इकडे 1 करेन. चालेल? Half unit distance on the right, half unit distance on the left I have taken. Then what is the neighborhood I found? 0, 1. Correct, na? Whether this open interval 0, 1 is contained in Q or not?
No.
No. Why? Yes. Answer no is correct. Let me make you this point clear. Answer no is correct. But I just want why this is not contained in Q. Between 0 to 1, whether all the numbers involved are rational. You have to think on this.
No.
No, surely not.
No.
Correct?
One is rational and after that number is irrational.
Between 0 to 1, rational and irrational both comes.
Yes, between 0 to 1, both rationals and irrational will appear. That's why this open interval 0, 1 should not be contained in Q. Therefore, may I write the same thing here? Half minus epsilon, half plus epsilon. Whatever is your epsilon value, this interval is not contained in Q. Correct, na? Therefore, the point half is for this point half, Q is not working as the neighborhood. Therefore, what is the statement I can make? The set Q is not neighborhood. The next video, neighborhood of any of its points. Correct, na? If you are having a doubt on this, you can ask me. You can stop me at any time and you can ask me. Okay. For one example, we have seen set of real numbers is neighborhood of each of its points, but set Q is not a neighborhood of any of its points. कोणत्याही पॉइंटचा तो neighborhood नाहीये. Okay. Now let me go for one more example. We'll just think of open interval. Now you tell me whether this open interval is neighborhood of each of its points. This is the real line and the set we have taken under the consideration is open interval AB. What is the meaning of open interval AB? Whether the points are included or excluded.
Excluding.
Excluded.
Excluded.
Points are
Hmm.
excluded.
Excluded.
And in which set they are included?
Close set.
Close the
Closed
set.
set.
In closed set, they are excluded. Now the question we are thinking is set AB, open interval AB, whether it is the neighborhood of each of its points. Suppose I have taken a point X here and I want to check whether open interval AB is neighborhood of X or not. येईल का neighborhood?
हो.
Yes, it is the neighborhood.
तो रिअल नंबर असला पाहिजे.
आपण रिअल लाईन वरच लिहितोय ना. AB
हा.
belongs to R is contained in R. रिअल लाईन मधला मी सेट घेतला एक. म्हणजे समजा 1 2 घेऊ आपण. 1 2 contained in R. करेक्ट ना. आपण इंटरव्हल कुठला घेणार आहे मी 1 2 2. असं मी फक्त इथे AB घेतला. आता इथे X जर पॉईंट घेतला तर whether the open interval 1 2 is a neighborhood of X is the question. Whether open interval is neighborhood of X or not.
Yes, it is.
Yes, it is. Okay. Because one can draw a small neighborhood around X. That open interval is contained in 1 2, and according to our definition, this 1 2 itself will be a neighborhood of X. And wherever is this location of X, हा X कुठेही जरी असेल, then also we can draw a small neighborhood around it so that open interval 1 2 will be the neighborhood of X. Therefore, may I say this open interval AB is neighborhood of each of its points? Correct now?
Yes.
Open interval AB is neighborhood of each of its points. Correct. Now let me change my question from open interval to closed interval. Now tell me the answer. What the change we have made? No doubt this is the open interval subset of R. Now what I have made the change? I have taken closed AB. What is the meaning of closed AB we have discussed? A and B
Include
are-
AB.
Yes, included. Now tell me whether this closed interval AB is neighborhood of each of its points or not.
Yes, it is.
Sure?
Yes.
Anyone else want to comment on this? Anyone else want to comment on this? Any student, other students? See, this is not a test I am taking. This is just an introductory discussion. You can talk with me very without hesitating. You can talk with me. करेक्ट ना. कोणी घाबरण्याचं किंवा टेन्शन घेण्याचं काम नाही. आपण एक डिस्कशन घेतोय. बरोबर. Whatever the answer she has given, whether everyone agree with this, that closed interval AB is the neighborhood of each of its points.
Yes, ma'am.
Yes,
Okay,
ma'am.
now if everyone is giving me an answer yes, what is an open interval around a point A? For inner points it is no doubt. What for the end point? As this is a closed interval, end point is also included. Then what is the small open interval around A? Whether this interval is contained in your closed interval?
No, ma'am.
Then how can you say that this AB is the neighborhood of A? I think you are thinking only for the inner points between A to B, na? You must think for A and B, boundary points as well.
Yeah. Yes.
Correct, na?
Yes.
Suppose this is 1 2, 1 2, and I am drawing an open interval around 1 from 0.9 to 1.
Mm.
0.9 to 1 is an open interval. Whether this open interval is contained in the interval 1 2?
No.
No.
It is not.
No, it is not clearly. Therefore, this closed interval is not a neighborhood of A. Correct?
Yes.
Similarly, for the second endpoint, however small open interval you draw around point B, that open interval will not be included in the closed interval AB. Correct, na?
Yes, ma'am.
Therefore, for the inner point X, it works as a neighborhood, but for the boundary points, closed interval AB is not a neighborhood. Okay, therefore I will write the closed interval. The closed interval AB is neighborhood of open interval, inner points only, na? Correct, na? But it is not a neighborhood of, endpoints A and B. Okay? Is everyone agree with this or not?
Yes, ma'am.
Yes, ma'am.
Now let me go for the next example. What do you think for the set 5? What is set 5?
Empty set.
Empty set.
Null set.
Null set, empty set, there are means. Okay. The question is whether the null set is neighborhood of each of its points. Confusing, na? The question is whether empty set is neighborhood of its points. Suppose I mark the statement that null set is neighborhood of its points, each of its points. Are you agree with this? What I will write? The null set phi is in neighborhood of each of its points.
There is not exist any elements.
There do not exist any element, correct? But we are discussing about neighborhood of its points, na? Therefore, can we make a statement null set is a neighborhood of its points?
Yes, because it is empty, so it will not be having any points.
Any
We
neighborhood points.
can consider that it would be neighborhood of each of its points.
Good. Actually, this statement makes a sense that because there is no point in phi of which it is not a neighborhood. What I'm saying, say, this statement makes a sense because there is no point in phi of which it is not a neighborhood. Okay, definition काय सांगते आपली? प्रत्येक पॉइंट फाय हा प्रत्येक पॉइंटचा नेबरहूड असला पाहिजे. मग आता फाय मध्ये असा एकही पॉइंट नाहीये ज्याचा तो नेबरहूड नाहीये. आहे का असा एक तरी पॉइंट ज्याचा हा नेबरहूड नाहीये? कॉन्ट्रापॉझिटिव्ह स्टेटमेंट वापर केली. ओके, in 12th standard I think you have studied logic, na? Contrapositive statements. Negation of a negation is the statement itself. Therefore, here I can make a statement that there is no point in phi. See, here I will write since there is no point in phi of which it is not neighborhood, not a neighborhood. करेक्ट ना? पॉइंट दाखवा, मग मी तो त्याचा नेबरहूड आहे की नाही सांगेन. तर त्याच्यात पॉइंटच नाहीये, त्यामुळे आपण काय म्हणू शकतो? असा एकही पॉइंट नाहीये ज्याचा तो नेबरहूड नाहीये, म्हणून हा नेबरहूड ऑफ इच ऑफ इट्स पॉइंट्स इज द क्लिअर स्टेटमेंट. करेक्ट? व्हॉट अबाउट फायनाइट सेट? अ नॉन एम्प्टी फायनाइट सेट. Finite set, whether it will be a neighborhood? Finite set neighborhood होईल का? Yes, students. A non-empty finite set, whether it will be a neighborhood? Is the voice audible? आवाज येतोय माझा व्यवस्थित?
हो.
अच्छा, कोणी रिप्लाय केला नाही, मला वाटलं म्हणून रेंज वगैरे गेली.
Finite sets consist finite number, so it not I consider not a neighborhood.
Yes, good answer. A non-empty finite set is not a neighborhood. of any point. Because to make a neighborhood, we want an open interval, na? For any x, if I want to check whether it is a neighborhood, we are considering open interval. And how many points we have in this open interval? Infinite points, no? This open interval, however small open interval we will take around the point x, that small open interval is going to contain infinite number of points. Therefore, a finite set is not a neighborhood of any of its points. Correct. Now I want to make some remark on the neighborhood. Okay. What about superset of a neighborhood of any point? Whether it will be a neighborhood. Superset of neighborhood of any point x. Whether it will be a neighborhood, superset I am saying, मोठा, bigger set containing the given neighborhood. होईल का? This is a point. Okay. Suppose this interval is a neighborhood. I'll call this as A set. Now we are considering the superset. Superset means a set containing A. Therefore, let me write this as a set B. Okay, therefore A is contained in B. Therefore, B is a superset of A. But if A is already a neighborhood of a point X, whether B will be a neighborhood? Whether B will be a neighborhood, set B will be a neighborhood. Yes, therefore superset of neighborhood of any point X is again a neighborhood. Correct, na? Again a neighborhood of X. Correct, na? What about union of neighborhoods? Union of neighborhoods. Union, it may be finite or arbitrary. What is the meaning of finite and arbitrary in union?
Finite means a finite number consists. Arbitrary means we explain the number is finite countable.
Yes, it is countable. Infinite one can check. See. Therefore, if I consider union of neighborhoods, okay, of a point X, whether it will be a neighborhood again?
Arbitrary.
Or finite? नहीं होगा? Suppose this is my point X and this is the neighborhood A I will call. This is some other set say B. Union of neighborhoods I am saying. Na? Wait. This is first neighborhood. Let me say this is the second neighborhood of X. A is first neighborhood. B is second neighborhood. What about their union?
Neighborhood.
Yes, it is a neighborhood. And it is possible in both the cases, finite or arbitrary. If I just mark more number of intervals like this, whether it will be the neighborhood of X or not?
Yes.
Yes, it is a neighborhood. Therefore, union, either it is finite or arbitrary of neighborhoods of points is a neighborhood of X. Correct, now? Good. Now the next definition we will start, second definition, interior point of a set. Interior point of a set. Can anyone tell me a definition? Yes, interior point of a set.
The point in between the set.
In between the set, okay. Inside the set you want to say, na?
Yes, ma'am.
I'll write the textbook definition first. A point X is an interior point of set yes if yes is neighborhood of x. Okay. In other words, x is an interior point of S if there exists an open interval. So I am saying open interval because we are discussing only real line, not two-dimensional space or not three-dimensional space, right? That's why I am writing in open interval. Open interval AB containing X. Containing X and contained in S. Okay, that is X belongs to open interval OB and open interval AB is contained in the set S. See, the definition is quite easy. X is an interior point if S is the neighborhood, or X is an interior point if there exists an open interval containing X contained in S. Right? It's not going straight. Right. This is a real line. A point X, I suppose this is my set S under the consideration. Then I want to check whether this X is an interior or not. For this, what we are doing? We are drawing a small open interval around X, and we will check whether that open interval is contained in the set yes or not. If it is so, then X is an interior point. If it is not, then X is not an interior point. Okay. हे मुलांना सांगताना मी काय सांगत असते माहिती का मी समजा आपण क्लासरूम मध्ये आहे आता नाही बट फिजिकल क्लासरूम आणि समजा एखादा विद्यार्थी दारात उभा आहे आणि शिक्षक शिकवत आहेत वर्गात तर तो जो दारात उभा राहिलेला विद्यार्थी त्याला तुम्ही आत आहे असं म्हणणार का वर्गाच्या आत आहे म्हणणार का
नाही
नाही म्हणू शकत ना आपण कारण तो बाउंड्रीवर आहे मग वर्गाच्या आत कधी म्हणणार मी त्याला एक पाऊल केलं पुढे यावं लागेल ना बाउंड्रीवरून आत बरोबर आहे ना बरोबर आहे ना आणि तो विद्यार्थी जेव्हा एक पाऊल आत येईल तर त्याच्या बाजूला मी एक छोटा ओपन इंटरव्हल एक ओपन डिस्क किंवा ओपन स्फिअर काढू शकते का जो त्या क्लासरूम मध्ये असेल ना समजा ही आपली अशी छान चौकोन क्लासरूम आहे इथे आपलं दार आहे समजा हा विद्यार्थी तो उभा आहे दारामध्ये जोपर्यंत दारात तोपर्यंत आपण नाही म्हणणार ना तो आत आला तो आत कधी येईल समजा तो एक पाऊल पुढे आला इथे आला करेक्ट ना दिसतंय ना सगळ्यांना एक पाऊल जेव्हा तो आत येईल तेव्हा आपण काय करू त्याच्या भोवती एक छोटा नेबरहूड काढू बरोबर तो नेबरहूड कुठे येईल मग क्लासमध्ये येईल ना जोपर्यंत तो स्मॉल नेबरहूड आतमध्ये येत नाही तोपर्यंत तो विद्यार्थी आपण वर्गात आला असं नाही म्हणणार आहोत ना आत आला असं नाही म्हणणार आहोत ना तसंच इथं आहे एक्स इज अ पॉइंट इफ आय वॉन्ट टू से इट इज अन इंटिरियर पॉइंट आतला पॉइंट आहे हे मला जर म्हणायचं असेल तर मी काय म्हणणार त्याच्यावरती एक छोटा ओपन इंटरव्हल काढायचा आहे आणि तो ओपन इंटरव्हल यस मध्ये असला पाहिजे तर तो काय झाला इंटिरियर पॉइंट झाला आता समजा एक एक्झाम्पल आपण घेऊ मी एक ओपन इंटरव्हल घेणार आहे ओपन इंटरव्हल 1 2 घेऊया आपण तर इथले जे सगळे मधले पॉइंट्स आहेत ना हे इंटेरियर पॉइंट्स होतील का येस दे आर इंटेरियर पॉइंट्स कारण कुठलाही एक पॉइंट घेतला त्याच्या शेजारी छोटा नेबरहूड टाकला तर तो 1 2 मध्ये येईल बट व्हॉट फॉर 1 हा बाउंड्री पॉइंट आहे ना 1 हा इंटेरियर पॉइंट होईल का whether this will be an interior point
No.
No, because however small I will draw an open interval around 1, it will not be included in the set 1 2 open interval 1 2. Therefore, 1 is not an interior point. Similarly, 2 is not an interior point. Correct, no? Getting me or not?
Yes, ma'am.
Yes. Therefore, a point is said to be an interior point if a small neighborhood around X is contained in the set, then only it is said to be an interior point. Okay, and collection of all interior points of the set is called interior of set. Correct, na? The set of all interior points. Set of all interior points. Okay. Correct now? What is the interior set? What is the interior of R? Can anyone answer then? A real number. What are the interior points for R?
Natural.
Okay, natural. Other than
Rational, whole numbers,
Rational numbers,
irrational numbers, integers.
Whole numbers.
काय राहिलं मग रिअल मध्ये सगळे तर आले पॉइंट्स
सगळेच आले मग.
मग काय मी असं करू का इंटेरियर ऑफ आर इज आर बिकॉज ऑल पॉइंट्स आर इंटेरियर पॉइंट्स ना
Yes.
okay if I switch to natural number what is interior point of natural number natural number चे इंटेरियर सांगा
All natural numbers.
are interior point
Yes.
anyone other want to answer check here I have drawn a real line R and what I have done I have just marked the natural numbers correct okay now we will check whether the first point 1 is an interior point of n or not what the definition says around the point you mark a small neighborhood and that neighborhood must be contained in n correct now therefore let me mark a small neighborhood around 1 is it so
No.
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 this is a neighborhood na first thing हा neighborhood आहे का
Yes.
हा neighborhood आहे
नाही.
हा neighborhood natural number मध्ये आहे का
नाही.
No.
oh, therefore 1 is not interior
Not
point
a
Not
neighborhood.
interior.
whether 2 is interior
Yes.
Yes,
Yes.
it is.
how around 2 also
No, ma'am.
Because
if I draw a small neighborhood around 2 whether this small neighborhood is in n or not या नेबरहूड मध्ये किती पॉइंट येतील समजा मी 2 चा नेबरहूड लिहिलाय 0.1 डिस्टन्स घेऊन लिहिलाय तर इकडे 2.1 होईल आणि इकडे किती होईल लेफ्टला
1.9.
1.9.
1.9 हा झाला नेबरहूड आता हा नेबरहूड n मध्ये आहे का
आहे.
No.
No,
Natural numbers are finite numbers, so
it
it is
does not
not
belong to
integral.
N.
therefore 2 is not interior 1 is not interior what about the remaining numbers
A
They
natural number
are not interior.
yes
natural numbers
natural number is
are
not
finite numbers.
actually interior therefore may I write interior of n is empty
Yeah.
interior of n is empty एकही इंटिरियर पॉइंट नाही आहे ना n मध्ये करेक्ट ना and same thing is for integers and for rationals they also do not have any interior points correct na yes or no students
Yes, ma'am.
Yes,
Integers
ma'am.
is also having interior empty set of rational numbers is also
Rational.
having interior
Empty interior.
empty good okay any doubt with the two definitions we have studied today neighborhood and interior only two I have taken okay now in the next lecture what we will do we will go for open set closed set bounds least upper bound greatest lower bound etc and etc therefore just give a revision to all these concepts okay so that it will be easy for me to discuss in the next lecture and if you are having difficulty about today's lecture any kind of difficulty you can post it on a Google Classroom or on our WhatsApp group also purposefully I have taken the basic definition and I have taken it in a very simple manner so that you can understand the basic concepts clearly then we will start our real analysis one syllabus okay Thank you for watching the lecture.